And now we will actually be talking about writing the equation of our straight line in something called gradient intercept form. So this looks familiar. It doesn't sound familiar, but it should look familiar to you. So gradient intercept form is just this: y equals ax plus c. Really what this is what you know as y equals mx plus b. It's the same thing. It's just this is the IB way of writing it. And this form is useful when given a graph of an equation, because in your graph you'll be able to find your slope, because it's rise over run, and you'll be able to find your intercept, your y-intercept. Now here's an example. Write the equation of the following line in gradient intercept form. So remember, that's the same thing as slope. So our equation is going to look like this: y equals ax plus c, where this is your slope, this is your y-intercept. Let's start this. So first thing I like to do is always find my slope. So I'll say, okay, I'll start here. It goes up 1, 2, 3, 4 over 1, 2, 3, 4, 5. So my a, or my slope, is 4 over 5. Now let's find our y-intercept c. Intersects right here. Y equals 1 right there. So c equals 1. And look, we've already got our equation. Y equals 4 over 5 x plus 1. Now with our lines, or with our equation of lines, we'll be able to figure out if lines are parallel or perpendicular. So we're going to start with parallel lines. So parallel lines share the same slope. We know that from Algebra 1. Or now we are in IB, we say gradient. All right, so here's the question. Find the equation of L2. Here's L2 right here. If it is parallel to L1, so that means they have the same slope. And L2 also passes through point -4, 0. First thing we need to know is, what's the slope of L1? Well, here's L1 too, or here's L1 right here. We have a point here and a point here. Let's find the slope. So the slope equals, m equals, or a equals, whichever one you feel comfortable with, equals, we'll say 6 minus 0 over 0 minus 4. That will give us 6 over -4. Reduce that and you get 3 over -2. So that means the slope of L2 is also this, because they share the same slope. They're parallel. Now we want to write the equation in this form: y equals ax plus c. Or remember, this is the same thing as a, because it's the slope. This is m, same thing. And so we'll say, okay, we have the slope. Slope is here. We need this one, c. Well, we don't know what this is on the graph, but we do have a point that's on L2. So let's use that x1, or x right here, and y right here, to figure out what c has to be. Let's fill it in. So we know y in here is 0, so I'll put 0 here for y, equals, my slope is 3 over -2, x, we're getting x right here, -4, plus c. Now we just solve for c. So 0 equals, when you multiply a fraction here by a whole number, you're multiplying the top. So 3 times -4 is -12. So -12 over -2 plus c, all that equals 0. 0 equals, so you divide that, you get 6 plus c. Subtract 6 from both sides, so -6 equals c. So my equation is, y equals 3 over -2 x minus 6. Now, perpendicular lines. So, remember from Algebra 1 and 2, we know perpendicular lines have opposite reciprocal slopes. Well, we define that a little bit differently in IB. We say if two lines are perpendicular, the product of their slopes equals -1. So let's start here. This question: find the equation of L2. L2 is right here. If it is perpendicular to L1 and shares the same x-intercept. So first thing first, let's take care of that perpendicular slope. We need the slope. So here, if you notice, this equation is in standard form. To help us out, we can change it back to gradient intercept form by just getting y by itself. So if we have 3x plus 4y equals 24, let's get y by itself. Subtract both sides, 3x. And now we have 4y equals 24 minus 3x. And then divide both sides by 4. So we'll get y equals 24 divided by 4. That will give me 6. And then we have negative 3 over 4 divided by 4x. Which means for L1, so L1 slope equals negative 3 over 4. And like you remember from algebra 2 or algebra 1, you say the opposite reciprocal is going to be the slope of the perpendicular line. So that means that L2 slope must be positive 4 over 3. And like we said, the product of the slopes must equal negative 1. So to check this, I'll just multiply it. So this times negative 3 over 4. And if you multiply those two, look at that. This cancels here. This cancels here. And all we're left with is a negative 1. So that's true. These are perpendicular slopes. So the slopes of L2, slope of L2 equals 4 over 3. So now we need to know the intercept. Well, again, we don't know what the y-intercept is here, but we do have a point that they share. And it's the x-intercept for this line. What I can do is I can say, okay, let's find the x-intercept of this line here, L1. Well, the x-intercept, we know that y equals 0. So I'll put that in for y. So 3x plus 4, 0 equals 24, which means that we have 3x equals 24. X must equal 8. So at this x-intercept here, the coordinates should be 8, 0, because y is 0, and we got 8 for x. So now we know that point on L2. So now we can find C for L2, the y-intercept. Now watch this. We know so far the equation is going to be, doing this color, the equation is going to be y equals the perpendicular slope x plus c. We're going to use this point here to find out what c is. So here we know if x is 8, y is 0. So y is 0, 4/3. We know x is 8 plus c. So again, I multiply 4 times 8, multiply on the top. So I have 0 equals 32 over 3. And then plus c. And what I'm left with is if I just subtract this from both sides, I get negative 32 over 3 equals c. So my equation is y equals 4 over 3x minus 32 over 3. That's the equation of the perpendicular line.